Okay, hi 3A. Now we are going to move on to actually learning how to calculate the empirical and molecular formula. So by the end of this section, you should be able to learn how to calculate the empirical and molecular formula of a compound from a given data. Okay, so you should be referring to your CAB page 80 and 81, and you should be able to complete questions 6, 7, and 8. Okay, so first of all, let me just introduce what is empirical and molecular formula. Okay, so empirical formula and molecular formula are, this is the first time you might be seeing them. It just shows the simplest whole number ratio of different atoms in a compound. Whereas molecular formula shows the actual numbers and kind of atoms present in one compound. Okay, so let me give you an example. Let's look at ethene. Okay, ethene has a molecular formula of C2H4. So if I were to actually change it to its empirical formula, which is the simplest form, it will be CH2 in this case. Okay, so do take note that empirical formula shows the simplest and it must be a whole number ratio. Take note it must be a whole number. So in your formula, there should not be any decimals over here. Okay, so now you might be wondering, why is there a need for me to learn this empirical formula? So let's say we take a look at this structure over here, which you have just learned. It's actually a giant ionic lattice structure. So you can see that there are many sodium and also chloride ions that are attracted to each other. Okay, so actually sometimes we have been using the empirical formula, maybe because we didn't mention it. Okay, but we do use the empirical formula from time to time. Okay, and other than that, we also have our metal, which is the giant metal metallic lattice structure. So in this case, giant metallic lattice structure is made out of many metal cations. They are embedded in a sea of delocalized electrons. Okay, so let's say there's like 10,000 sodium cations, okay, in this case. And the empirical formula, which is the simplest form, will just be Na. Okay, so let's take a look at other structures, like let's say our silicon dioxide, which has a similar structure to diamond. So now think about it. Are you able to simplify it to its empirical formula? Okay, if you have think through, it should be SiO2 in this case. Okay, and we also have our graphite. In this case, it is made of many carbon atoms that are held together by numerous covalent bonds. Okay, so the empirical formula will just be carbon. Okay, other than this giant structures that we have just learned, okay, just to share with you, there are also polymers which you will learn at the later part of this syllabus. Okay, so polymers are also a continuous network of like atoms that are covalently bonded together. So in this case, a polymer will be C maybe 20,000, H 30,000, Cl 1,000. If you were to simplify it, it will be C2H3Cl. And also our DNA structure, for those bio students, you should know that DNA is actually a very long repeating unit of structure. So it is also a giant structure, and sometimes using the empirical formula will be more useful in our calculations. Okay, so now we're going to learn how to find the empirical formula of a compound. Okay, first step is to find out the mass of the reactants taking part in order to manufacture the compound. So this first part, the mass, is usually given in the question. Okay, step 2 is to work out the relative numbers of moles, which is the amount of substance, the reactants that's being used. And step 3, which is to find the formula using the mole ratio obtained. Okay, so now I'm going to illustrate these 3 steps using the example that's on your CAB page 80. So in the question, 24 grams of carbon was found to combine with 4 grams of hydrogen to form propene. And what is the empirical formula of propene? Okay, so as you can see on page 80, we actually use a table to actually present our answer. Is it necessary for us to actually have this table all the time? Okay, the answer is no. You can choose to present your answer without a table, but I think it is better if you could use this table because it is more structured, and at this point of time when you're still very new, it is better to be a little bit more organized. Okay, so this is how a table should look like. Okay, you should have your list down the elements, okay, the mass given in the question, and the molar mass used in this case. Okay, please take note that the molar mass, I'm referring to just one atom. So for carbon, it is 12. For hydrogen, it's just 1. Okay, then you are supposed to work out the ratio in this case. So you go and after calculating, you should get this first. Okay, this so you realize that the ratio of carbon is to hydrogen is 2 is to 4. Okay, Then the next step is actually to find the mole ratio, which you need to simplify it. So 2:4, you can simplify it to 1:2. Okay, always make sure that your empirical formula, sorry, this is not magnesium oxide, sorry, this is propene. Okay, it is CH2 in this case. Okay, so please take note and make sure that you always put it to the simplest form. Okay, if you are clear about this example, you can do question 6 on your own. Okay, so from this point onwards, you can choose to pause the video and complete question 6. Question 6 will be released only as an answer because it is not included in my PowerPoint slide. Okay, so do check your answers for the next 3 questions. Okay. Okay, now I'll move on to question 7. Okay, question 7 is similar. So question 7 states that sodium azide reacts with dilute hydrochloric acid to produce sodium chloride and a compound A. Compound A contains 22.33% of hydrogen and 97.7% of nitrogen by mass. Calculate the empirical formula of this compound and suggest the name of compound A. So what is different about question 7 and the previous question is that instead of the mass given of the respective elements, I've given you the percentage mass. Okay, so how do I go about doing it? Okay, so in case you are not too sure, percentage mass is actually referring to the amount of element that's present in a compound. Okay, so whenever you get a percentage, you can first assume that the mass of compound A is 100 grams. Okay, so if compound A is 100 grams, think about it, what is the mass of hydrogen? And what is the mass of nitrogen that's present? Okay, so you should have worked out that, okay, the mass of hydrogen is 2.33 and the mass of nitrogen is 97.7. Okay, so similarly work out using the same table. Okay, you should be able to work out the mole ratio and also the simplest mole ratio. So nothing is different from this example and the previous example, except that, okay, it is important to recognize and understand that when I give you the percentage, you can directly divide it to the molar mass because we can assume that the mass of the compound given is 100 grams. Okay. So after you work out, you realize that, okay, you have a not very nice number. So what can I go about doing it? Okay. So you just need to use whichever is the smallest number and divide them accordingly. So 2.33 can divide it by 2.33 and 6.99 you divide by 2.33. So the simplest mole ratio will be 1:3. Okay, and you should know that this will give me the empirical formula of NH3. And you probably should know by now that this is actually ammonia. Okay, so that's how you work out the empirical formula for question 7. Okay, now I'll move on to question 8 in this case. Okay, question 8, similarly to question 7, there are also the different percentages that's given over here. Okay, so you can actually work out your formula, your empirical formula accordingly. Okay, so I'll give you time to go and do it. You can pause the video now. Please pause. Okay, and start to work out using the table. Okay, so those of you who are done with your own calculation, you should be able to get something like this in this case. Okay, I think that by now you probably have realized that the number over here, it is 1.34. So if you recall just now, what did I mention about the empirical formula, which is a whole number? Okay, remember the empirical formula must be a whole number. Do you think you can write CH 1.34O? Or did any of you went to round down this number in this case? Okay, I hope you don't round down. You're not supposed to round down any numbers in this case. Okay, so now you have to think about it. How do I make this number into a perfect whole number? Okay, so these are some tips and strategies on how you can go about doing it to get a whole number. Okay, so one way is you can go about multiplying by 2, by 2, by 2 over here. Okay, or subsequently by 3, by 3, by 3, so that you can remove the decimal points and you can get a whole number. Okay, so if you're not very sure of what I'm talking about this, you can refer to the table over here. Okay, okay, so in this case, right, you notice that whenever you get the simplest mole ratio, you have various decimal. You need to multiply, let's say if it's 0.5, you need to multiply by 2. 0.333, you need to multiply by 3. Okay, the reason is because I'm trying to round off the number to the nearest whole number in this case. I'm trying to round off it to the nearest whole number in this case. Okay, so do you need to memorize this table? Okay, I think there's no need to memorize this table. What you can do is that in exams, you can choose to press the numbers by steps, like let's say times 2, to see if actually it gives you a nice whole number. Then times 3, times 4, and times 5 subsequently. Usually, you are not expected to times more than 5. Okay? But looking at this number 1.34, which decimal is it closest to? Okay, I hope you know that it is closest to times 3 over here. Okay, so when you multiply by 3, okay, this will give you a nice whole number of 4. And you don't forget to multiply this by 3 and by 3. Okay, this is like how you learn ratio in maths. Whenever you multiply something, you have to do it the same for the rest. Okay, so you have obtained the empirical formula to be C3H4O3. Okay, so some of you who still are not very sure what do I mean by this decimal and this multiplication, I'm just trying to educate you and let you know that you need to get a whole number in your empirical formula. Okay, so you just need to try to multiply by a number over here such that you achieve a whole number at the end. Okay, so if you still face and encounter difficulties at this point onwards, please speak to your respective subject teacher, myself, or Miss Karishma to help you to understand this part. Okay, so this is something quite crucial. Okay. Okay, now I'll move on because in the question, they did ask you to calculate the molecular formula of vitamin C. Okay, so using the empirical formula, how should I go about calculating the molecular formula? Okay, so first question is, how is the empirical formula of a compound related to its molecular formula? Okay, actually, if you notice, right, just now when I give the example of a propene, ethene, C2H4, when I simplify it to CH2, actually the empirical formula and molecular formula, they are just a multiple of each other. Okay, so we will always be able to find if we have the empirical formula, okay, and also the relative molecular mass, okay, if we want to find the molecular formula. So in the question, we have already found the empirical formula to be C3H4O3. Okay, and there's also the relative molecular mass given, which is 176. Okay, so how do I go about doing it? Okay, so this is something like an example. So if I have an empirical formula of AXBY, okay, the molecular formula will be something AXBY bracket N, whereby N equals to 1, 2, or 3. Okay, so then after that, we'll calculate N by using the relative molecular mass. This is always given in the question, divided by the relative mass of from the empirical formula that we have calculated. Okay, so what do I mean? I'm going to give you an example using the previous question 8, sorry. Okay, so question 8, we have found out that the empirical formula is C3H4O3. So this means that the molecular formula is represented something like this. Okay, so now you need to go and find what is the value of N. Okay, so N, okay, so if you were to do something like this, you realize that I need to add the empirical formula here times N, which will equate to 176. Okay, so referring to the previous formula just now. Okay, and then 88N equals to 176. Okay, so N, when you calculate it, you get N equals to 2. This means that, okay, for my molecular formula, it will be C6H8O6 because I need to multiply all these numbers by 2. Okay, so this is how you go about calculating the molecular formula of vitamin C. Okay, with that, I will stop here. Okay, this is what you need to learn for this topic, for this section over here, empirical and molecular formula.